Okay, today we're going to be doing the first 12 problems from the 2020 AMC 10A. Let's get right into it. I haven't seen these problems yet, so hopefully, bear in mind if I take a while to solve them. I'm kind of putting myself under test conditions. So for the 12 problems I'm going to do, I'm going to have basically 3 minutes per each, so I should be able to get this done within 36 minutes on average. If less than that, great. Okay, for what value of x does this equation satisfy x? So basically, about a 6, right? That's just e. So if they have an average arithmetic mean of 15, that means that that's the average of the two terms. There's c. So what is the value in simplest form of the following expression? We know these are negative inverses, and so are these, and so are these. Therefore, the answer is just negative 1 cubed. Negative 1. The driver travels for 2 hours at 60 miles per hour, during which her car gets 30 miles per gallon of gasoline. She's paid 50 cents per mile, and her only expense is to gasoline at $2 per gallon. What is her next rate of pay in dollars per hour after this expense? So we know that because she gets $0.50 per mile, in an hour she gets $30. And then in hours she pays $4 for her gasoline, her expenses. So it's just 26, her next rate of pay. What is the sum of all numbers x for which this is true? This is just basic, very basic algebra. The tests are getting very easy. So I know I can find this as x minus 6 squared. I can find this as x minus 8 times x minus 4. And that's just 8 plus 4 plus 6. As the discriminant is 0. So that's just 18. Let's see. How many 4-digit positive integers? That is between 1,000 and 9,099 inclusive, having only even the digits are divisible by 5. So let's just proceed to set up our combinatorial, not combinatorial, what do you call this? I think it's, I'll just call it like slots. So we know that the last digit could be 0 or 5. But we know that it can't be 5 because it's an odd digit, so it has to be 0 and we only have one choice. The second one, we have 5 choices, as we have 0, 2, 4, 6, 8. Same with this one, we can't have a 0, otherwise it wouldn't be a 4-digit number, so we have 4 choices here. So the total number is just 4 times 5 is 100. 25 integers from negative 10 to 14 inclusive can be arranged to form a 5 by 5 square, which is the sum of the numbers in each row, the sum of the numbers in each column, and the sum of the numbers along each of the diagonals are all the same. What is the value of this common sum? So we know that we can just find the sum of this. To cancel the negative terms, the positive terms, to simply just get 50 for this sum. And we know that 50 divided by 5 is the common sum. What is the value of this? So what can we do? So we can group the 4 terms. We have 3 positive and 1 negative for each one. So that's just 2 plus 10 plus 18 plus dot to dot all the way to 394 using the formula a plus n minus 1 times d. We use the common difference. We know the sum of the terms is 0, 4. 2, you just kind of get some more space. 2 plus 394 divided by 2 times 50. Which could balance the same thing as 198 times 50. Which is, I don't know this by heart, but I think it's 9. Well, let's just evaluate this. Maybe we can, just to be sure our answer is correct. We don't want to estimate to be B, but let's just double check. 0, 0, that's just 0, 0, 0 plus 0, 0, 4, 4, 5, 4, 9. Sorry, 9, 4, 9,900. So it is B. I was right. Okay. Next problem. So, single bench section at a school event can hold either 7 adults or 11 children. When n bench sections are connected end to end, an equal number of adults and children seated together will occupy all the bench space. What is the least possible positive integer value of n? So we know we have to, I mean, it's pivotal to find the LCM, right? LCM, 2 prime numbers, is the product of the numbers. Okay, that's pretty important. We also know that we can have 11 bench sections with adults and 7 with children, so we could just have 18 total bench sections. That's simple. Okay. 7 cubes whose volumes are 1, 8, 27, 64, 125, 216, 343 cubic units are stacked vertically to form a tower which the volumes of the cubes decrease from bottom to top. Except for the bottom cube. The bottom face of each cube lies completely on top of the cube below it. What is the total surface area of the tower in square units? So this may seem somewhat of a, I don't know, a peculiar problem to you, as you know, you don't really deal with this a lot, but if you think about it, we know that the surface area of a cube is always 6s squared. And I don't like getting too formulaic, but this problem is actually using logic and like reason. So if we have like a cube, like a lot of cubes, right? Okay. So it's not going to be like perfect. I mean, the cubes aren't so great. But then we have another cube stacked completely on top of it, right? But we know that this is completely on top of it. And basically, what does that mean? That means that even though the volume is different, we're of course stacked. It lies completely on top of the cube below it. So we know that it lies completely on top of it. We know that the first one, we're going to have 6s squared. The second one, or the remaining ones, we're going to have 4, because we have 4 faces here. 1, 2, 3, 4. Okay. No, 1, 2, 3, 4. But then we're going to count another one, right? And then we're going to have another one, right? And if you think about it like from a 3-dimensional, like imagine you're like looking at these cubes, what is the actual total surface area? We're not counting the bottoms. So it's just 4 for each. So 4 times the remaining 6 squared plus 5 squared plus 4 squared, which is just that plus. Which is, I believe, let's see, 61, 77 plus 14. 81 times 4. This should be 91, sorry. Wait. So we have 77 here. So okay, I'm tripping. So we have 77 here plus 14. We have 81 times 4. You have 6 times 49, right? So we should have what? What value are we gonna get? 200. 94 plus 321. Doesn't seem right. 50, okay, we're gonna have 50, 61 plus 16 is equal to 77 plus basically 14. 80, 91. Okay, obviously 91. Okay. Should be 91, not 81. Simple mistake there. Okay. Gotta be careful. You gotta watch out for those simple mistakes, guys. Simple mistakes is what gets you. Okay. Oh, sorry. 658. B. What is the median of the following list of 4,040 numbers? So right off the bat, median will equal basically 2021st number plus the 2020 set, or 2020 plus the 2020th number divided by 2. And wait, divided by 2? Yeah, that's the median. Okay, so because we don't have an odd number term, so we can't do that. Anyways, so so I have all these cubes. I want to see what square basically fits in this sequence. Like what square fits in this sequence? Okay. So let's see. I know maybe we could try out 45. Like maybe I know 50 squares is 2,500. Maybe 45 will work. Hopefully. What is this? Let's evaluate that to be 5 to. I'm trying to do this in my head. That should be 25. Okay. So that doesn't fit in this sequence, but we know 44 squared will definitively fit in that sequence. And we know it's 45 plus 44 less than this, or simply 89 less than this, which would mean that it is, that's not true. One second. Let me just evaluate this. So I don't want to mess up. Eight, 9, 1, 3, 6, 9, 3, 6. So 44 squared. Okay, it's pretty important. Okay. So we know that we basically traverse the 44 squared in this set. So we know that 44 squared, let's call it set A and alpha. Okay, 44 sets in the set alpha. Okay. We also know that 44 squared, we also know 1936 is the 1936 plus 44, or the 1980th term. Because we have no more perfect squares, or PS, no more PS, we just add 40 to get that the 2020th term is 1976, 2021st term is 1977. Add these two to get that, some quantity divided by 2 to get the average of them at 1976.5. C. Okay, let's just erase some of this so we have a bit more space. I'll just erase my work here. Okay, so C. Anyways, triangle AMC is isosceles with AIM equals AC. Means MV and CU are perpendicular to each other. So we have medians. We know that we can create similar triangles from medians. We can draw this, and we know that this is similar because these are medians. And we know that AUV is similar to AMC. We have parallel lines. We have similar angles. Therefore, they're similar. And we also know because we have medians, AUV basically divided by AMC in terms of, let's just put side lengths, basically equals 1/2. So we know that the area length is the area length is 1/2 squared. Of course, we know that basically AUV equals 1/4 of, what's the, okay, it's MV times C, so these are all 12, okay, so we know it's 12 times 12. The area of this, the quadrilateral here, we know it's 12 times 12 divided by 2. Just using diagonal products and medians, which is 72. So you know that AV is 1/4 times 1/4 of 72 plus AV. Yeah, so it's obviously it's 18, sorry. 17 plus 4th times AUV. 3/4 AUV equals 18, which means AUV equals 32. 34, because I want, I want 33, so it's 34. Which means that 34 plus 72 is... not 34. Where'd I get 34 from? What? Let's go back. Okay, so we know that 3/4 AUV equals 18. 72 equals 3UV. AUV equals what? 26, right? 24. 24 plus 96. See. And we're done with the first 12 questions. There we go.